Hi, my name is Izabelle Young, and the title of my project is Developing a Novel System to Combat Space Radiation and Neurodegeneration Using Electromagnetism. Realistically, if long distance space travel and habitation of Mars are to be achieved, the effects of harmful space radiation must be prevented. Space radiation is comprised of atoms in which electrons have been stripped away as the atom accelerates in interstellar space to speeds approaching the speed of light. Eventually, only the nucleus of the atom remains. Beyond low Earth orbit and Earth's magnetosphere protection, space radiation may place astronauts at significant risk for radiation sickness and increased lifetime risk for cancer, central nervous system effects, and degenerative diseases. Research studies of exposure and various dosage and strengths of radiation provide strong evidence that cancer and degenerative diseases are to be expected from exposure to galactic cosmic rays or solar particle events, which are forms of space radiation. It is also ionizing radiation, meaning it has the ability to move through substances and alter them as it passes through, including space shuttles and necessary equipment needed in space. When this happens, it ionizes the atom and the surrounding material with which it interacts. Ionizing radiation is like an atomic scale cannonball that blasts through material, leaving significant damage behind. Therefore, the purpose of this project was to test the effectiveness of the electromagnetic glove system in blocking harmful radiation from X-rays as a proxy for space radiation. Possible harmful effects were analyzed using Jujisia tigrina, better known as planaria, and Daphnia magna, which will be placed in the electromagnetic glove section that contains Faraday fabric, preventing electromagnetic radiation effects. I hypothesized that if the proposed electromagnetic glove system is in usage while the X-ray is on, then specimens in the electromagnetic glove system will be protected from the harmful effects of the X-ray, as shown in near normal locomotion of the planaria and the normality of the Daphnia's heartbeat. Prior experimentation involved planaria being exposed to an environment with a constant electromagnetic field at different heights with and without the inhibitor material, or Faraday fabric. Faraday fabric uses a copper and nickel composition. This is the same fabric that is used by military and law enforcement. Without the material, the planaria experienced less mobility and other atypical behavior, signaling decreased neurotransmission. These effects decreased when inhibitor material was present. This material was integrated into a glove section with various electromagnets, sensors, power supplies, and put into an electromagnetic corridor section. The design and workings of this glove electromagnetic assembly is actually joint patented by me and my sister, who worked on the experiment with me last year. A computer program controlled glove components created involving small electromagnets and 3D printed holders. Glove was put through series of calibrations and experimental tests. As the glove moved in the electromagnetic corridor, the program used sensor data to change the current flowing through the various glove electromagnets to compensate for the force differentiation between the electromagnets. The glove and inhibitor material were successful in blocking the electromagnetic field harmful effects and also simulating the effects of gravity. Thus, I wanted to see if the field that emulated last year would prove to be also a good prevention system in the blocking of space radiation, like the Earth's electromagnetic field. I chose to use planaria due to their neurochemistry of pathways, their primitive but vertebrate-like nervous system, their mammalian-like neurotransmitters, and their simple pharmacokinetics. The Daphnia magna were chosen because their heart rate is able to be quantified and stressors on their system can be found and identified. They also contain the most amounts of genes than any animal, showing that they have quite complicated systems. To begin my testing, I created a 3D printed model to hold my specimen, endoscopic camera, magnetic flux meter, and a Geiger counter, which connected to a Raspberry Pi. I built my own Raspberry Pi by using a kit and soldering the pieces together, which I would use for my data storage. This part of the project I really enjoyed as I was able to successfully make the computer I built work. Here is me working on the Raspberry Pi, and here is my 3D printed model. My first test was a control in which the planaria and Daphnia were exposed to no stressors and swam around in their environment for 10 minutes. Each specimen was recorded and held using the 3D printed model and a camera mounted upon it. Those results became the baseline of the specimens. As you can see here, there is the track of the planaria, and it's a straight gliding motion. And here's the neoblasts, where you can see that they're quite plentiful. Then the specimens, both planaria and Daphnia, were exposed to X-ray radiation for a 10-minute period. The camera captured video and was analyzed by ImageJ worm track, which accurately analyzes the speed, velocity, distance traveled, and bends per second using the path they traveled over the 1 centimeter by 1 centimeter grid line paper their holding container was held over. This is commonly known as the PLMV method. The results quantified their locomotion and thus showed the effects the X-rays had on their neurofunction. The planaria were then analyzed under a microscope for morphological changes. Daphnia testing was also done, in which the video was analyzed using NIS element software to calculate the heartbeats per minute underneath the microscope. The NIS element software is an accurate method to precisely measure their heartbeats with no loss of count due to human error. After the testing of the specimens were done, exposure was converted to millisieverts because astronauts are exposed to ionizing radiation with effective doses in the range from 50 to 2,000 millisieverts. 1 millisievert of ionizing radiation is equivalent to about 3 chest X-rays. Due to possible harm constraints, I could not use a radiation that would output higher radiation amounts than a dental X-ray. Nonetheless, the dental X-ray radiation, when scaled to the planaria and Daphnia, was equivalent to a large amount of radiation outputted on their system since they are small creatures. As you can see here, this is the ImageJ process, and this is the path analysis of the planaria when exposed to X-ray. As you can see here, there are small bends, which is really bad on their systems. And here's the NIS element software. And here is the X-ray with the 3D printed specimen holder. The analysis found that planaria experienced less locomotion, speed, velocity, and distance when compared to the control, showing the negative effect the X-rays had on their neurological functions. Planaria also displayed highly atypical behavior called C-shape hyperkinesis. This is when a planaria curls up into a C shape and move in this position. It shows that the planaria were highly uncomfortable in their environment on being in exposure to the X-ray. They displayed shrunken heads and shriveled bodies, showing degeneration of their nervous system. Planaria were also seen to have less neoblasts that account for about 30% of all cells in them. Neoblasts give planarians the ability to regenerate lost body parts, showing that the X-rays would have inhibited not only the neurofunction of the planaria, but also its regenerative properties. Daphnia also displayed negative effects. After 10-minute exposure, their heart rate greatly increased, and in a matter of minutes, they perished, demonstrating the detrimental effects X-rays have on their circulatory system and overall function in general. Next, the electromagnetic glove system and X-ray were turned on simultaneously, while specimens were kept in the glove for 10 minutes. Positive effects of the glove system were found. The electromagnetic field system redistributed the radiation from the X-ray, similar to the way Earth's magnetosphere redirects space radiation exposure. Earth's magnetosphere redirects this radiation towards the Van Allen belt, now filled with high amounts of radiation. In turn, this redirection showed positive effects on the specimens. Both planaria and Daphnia had near normal locomotion and heart rates. No morphological changes were seen as greatly as they were in the X-ray exposure. Here's the system with the X-ray, and here's the path analysis of the EM field and the glove, as well as the X-ray exposure. And as you can see, it is more straight and had more gliding than is previously seen in the X-ray. Therefore, the hypothesis was proven correct by the data of the experiment. The electromagnetic glove system proved useful in combating the X-ray exposure, showing that not only does the system prevent against muscle atrophy from microgravity, but possible neurodegeneration from space radiation as well. This system can be applied to future missions and long-distance space travel, including habitation of Mars. As astronauts travel into space, the loss of Earth's natural gravity exposes them to risk of muscular and skeletal atrophy, and when they return to Earth, they would not be able to live in Earth's normal environment. The system can introduce an artificial gravity and magnetosphere to space, subverting these effects. The system application to Earth is that it can help with physical therapy and also create a microgravity environment for recovering physical therapy patients. They could feel less weight on Earth, which would help with recovery time and healing. Also, the electromagnetic glove field system can prevent against possible radiation on Earth, maybe from solar winds repositioning the magnetosphere and exposing Earth to solar particle events. All in all, the system can be used in both Earth and space environments for the protection and fostering of human health in each environment. What my future experimentation will probably involve would be creating a space radiation detective and warning system, which would be in the corridor the electromagnetic field system and suit will be held. I would like to see it in maybe the International Space Station, and it could help astronauts realize when a solar particle event is coming on, and then they go into the corridor and then be protected from the space radiation. Thank you.